pH conditions, which are beneficial for them, because it's easy to move water across membranes that way. It doesn't require a lot of energy to do so. As you increase or decrease the pH, it becomes more difficult to move the water. If you increase it too much in one way or another, you'll start to get caustic and it will burn. Acid burns are not fun. Alkaline burns are even worse. All right? So the pH of your stomach is around a 3. So is the Coke that you drink, which is kind of interesting. All right? So pH can really have a limitation on species distributions, as can salinity. Too salty, too fresh, too dilute, and you'll limit the distribution of organisms that are intolerant to the other condition. Currents and oxygen are really important. We talked a lot about currents with the barnacles and their basic movement patterns affecting distribution. Oxygen is also really critical. So in a lake system, oxygen is really important for limiting the distribution of organisms. Anybody ever swam in a natural lake before? Raise your hands if you have. So when you swam in it, the top can feel like 80 degrees, but go down like 2 feet and it's freezing, or 3 feet and it's freezing. You ever done that? So it'd be like super warm, and then you like stand, you're like you're doing a, what's it called? You're just standing there, treading water. Thank you. Treading water, right? And your feet are in freezing cold water. That's called a thermocline, and that's oxygenated rich water on the top and oxygen-rich water on the top and oxygen-poor water below, caused by a thermal gradient. And so that can really limit distribution. If you're a fish, can I live in the bottom water? There's no oxygen down there. So where am I forced to live? In that 3 feet of surface, because that's the only place I can get oxygen. And the whole bottom of the lake is now excluding me. All right? So that's another example of how these abiotic factors can limit distribution. So let's summarize this all up. We've learned some tools about how to look at distribution. We've learned some lessons abiotically and biotically. And so as an ecologist, how would you address any problem of distribution out in the world? And so a simple way to do it is to kind of think about it from a flow chart perspective. And you can go either backwards or forwards. I'm going to present the most typical way that it's described in the textbooks, but I actually go the opposite way, and I'll talk about that too. So here's my question. Why is it here but not there? The first thing I want to look at is, well, it's not there because it can't get there. So that's dispersal, and I investigate that via experimentation and observation. If they just can't get there, well, it's dispersal. Area is inaccessible. That's why they're here but not there. Solved. But if it's not that, then I look further. And I say, well, maybe it's behavior. They choose not to go there, or they don't recognize it as a usable habitat type. If that's the case, behavior dictates it. The tree picker was a nice example of that, right? So that would be habitat selection. Well, what if it's not habitat selection? Well, then I look at other species. Maybe it's here but not there because it's being outcompeted over there. Maybe there's a predator or a disease over there. Maybe I didn't bring my symbiote with me and that's why I died, right? Like the kiwi and then the pine tree, something like that. So if that's the case, great. It's other species, biotic interactions are what limits the distribution. Well, what if it's none of those? What do I have left? I have all the abiotic factors, right? So I can look at the physical, chemical factors of any environment. I can look at the physicality of, maybe there's not enough light over there for the plant, or there's too much light. It's too hot, it's too cold. The soil structure, it's too dense, it's too porous, it doesn't hold enough water, holds too much water. The fire frequency